Hello again. Let's look at this paragraph first, and then we'll do an example. If we regard x as the dependent variable instead of the independent, and y as the independent variable instead of the dependent, then we can actually find dx by dy in some situations. And I need to put in some situations. But I don't want to get too theoretical, but as it turns out, if dx by dy and dy by dx both exist, then neither one will equal 0, thankfully. And dx by dy in the vein of fractions will equal 1 over dy by dx, consistent with the behavior of fractions. Now, guys, keep in mind there's a little more to a derivative than just a fraction. But in a lot of ways, dy by dx really acts like a fraction, where dy is a teeny tiny quantity and dx is another teeny tiny quantity, and we divide them by each other. Now, that's just intuitive. There's a little more going on than that. But anyway, let's look at this. If y equals x squared and if x is greater than 0, this is the standard parabola, and we just want to look at the right side, not even the origin. We just want to look at the stuff purely in quadrant 1 for y equals x squared. Then for quadrant 1, dy by dx will equal 2x, while on the other hand, dy by dx, now that's going to equal dy by dx of x squared. Guys, we can just handle that by implicit, really. That's going to be, now, here's the deal. Dy by dy, that's just 1, right? I can say a lot more here. Guys, dy by dy, that's just 1, because the derivative of y with respect to y himself is just 1. So now dy by implicit differentiation, d by dy of x squared, that's 2x, but since x is a foreign variable relative to y, we got to do dx by dy. And I'll get rid of that annoying, that time sign is okay, but I find it annoying. We know what's going on. Okay, you got to stick dx by dy there because we're derivating with respect to y this time. Okay, and now that implies that 1 equals 2x dx dy. And sure, we said as much right here. And then just divide both sides by 2x. Guys, remember, x is greater than 0, so we don't have that division by 0 thing to worry about. So that just implies that 1 over 2x is dx by dy. Just divide both sides by 2x, and you've got it. Now here's the thing. Remember back when y equals x squared, if we did dy by dx, on the other hand, we would have just gotten 2x. We'd derivate both sides with respect to x. In other words, dy by dx would just be 2x. Oh, dx by dy is 1 over that 2x. They're reciprocals. They behaved as we think they ought to behave. They're behaving like fractions. Even though intuitively what we're kind of doing is divide an infinitely small dx by an infinitely small dy. But there's more to it than that deep down, but intuitively you can think of things that way. Okay, it's just behaving like a fraction. Dy by dx is the reciprocal, as long as both of them make sense and all that, and you're in a good situation to do them. Guys, if the only time that would ever fail, if dy by dx equaled 0, you couldn't find dx by dy. You would have to, I don't recall the strictest conditions in which you can do them. I might get back to you later on that. We're not doing analysis here anyways. I'll always give you functions that will behave if I ever ask you to do any of this stuff. And so will your calculus professor too. Okay. Now if you get to advanced calculus and analysis, that changes. But anyway, if y equals sine x, and if x is in this open interval here between neg pi halves and pi halves, basically what I'm doing is what I did in the last example. I didn't exactly point it out. I was making sure our function stayed what you call one-to-one or injective, and that's what I'm going to do here too. I want sine to stay injective or one-to-one. In other words, two different x values will output two different y values. That's what injective means, and I want to keep it that way for some of these, just to make life nicer. I'll never make you make up your own functions, okay? So I'll only ask you to go straight. I'll give you a function already that's reasonably well behaved, and then I'll ask you to go in and dig out dy by dx or whatever it is I want you to find. Okay, and so will your professor. But if y equals sine x, and if x is in that interval, then well, I really can't tell your professor what to do, but I strongly suspect your professor will do that. They're not obligated to do anything, but I stoutly suspect that they're not going to make you go into analysis. Okay, but anyway, moving on. So if y equals sine x, if I would have differentiated both sides with respect to x, first off, before we move on, this would just give me dy by dx equals cosine x. Okay. But now I'm going to be, we're wanting to find dx by dy. So here's what we do. Yeah, I know what you're thinking. I could do the arc sine of y equals x, couldn't I? And derivate the arc sine, but nah, let's not. So dy by dy, I'm going to do it this way. So I'm going to differentiate both sides with respect to y. Now, guys, dy by dy, d of something by d himself is just 1. If this is a y and this is a y, or if this is an x and this is an x, if this is the exact same thing over himself, you always get 1. Okay, the derivative of a variable with respect to himself is just 1. So 1 equals that. Okay, but hey guys, we can deploy. This is just the, by implicit differentiation, well, and the sort of the chain rule, we derivate the sine and get the cosine, and then by the chain rule, we got to go inside here and do dx by dy. And I'm just going to, okay, that times sign, I just used it to get the guy over there. So 1, the point is, 1 on the very left equals this guy on the very right. So 1 equals cosine x dx by dy. Divide both sides by cosine x, and you'll get secant x equals dx by dy. And guys, remember, there's no danger. Cosine will never vanish, okay? So, but anyway, you don't have to bark up that tree, so you don't have to worry about the cosine vanishing. And really, this time, I really should have been a little more careful. I ought to put my stipulation in there, and cosine x does not vanish. But your professor, ask him or her if they're going to make you put the stipulation in. I got a feeling they're not. I got a feeling they'd be happy without this trigonometric stipulation. And 5 or 6 minutes ago when I did that other stipulation in that very first example, you might could leave that off and just leave it understood, but ask your professor first. Now, if you get to analysis, you'll probably need to put these on here, because in analysis, you have to have everything perfect. Now, calculus, I'm not saying be sloppy all the time. I'm saying, there's some, you don't have to cross every P and Q every time. But I'll assume that your professor is at least somewhat persnickety. So there's that. And guys, if the cosine, the secant, remember the secant is the reciprocal of the cosine. So the secant will exist if and only if the cosine is not 0. The cosine exists everywhere. But if the cosine is 0, your secant won't exist. It's a reciprocal. And if your cosine is anything else but 0, your secant will exist, which implies that the secant of x exists and the secant of x equals dx by dy. And indeed, the secant of x is the reciprocal of dy by dx equals cosine x that we talked about when I first started doing this problem here. So this is just a little spill on implicit differentiation. And about this whole business that I did on the very first problem of this video and this example right here when I put the cosine of x not equal to 0, ask your professor if they want you to put that in there. It's just because in that first example, if the cosine would have been 0, it'd have been a disaster. But this, that couldn't have happened anyway. Or it was the cosine of x plus y in that first example. It's just the cosine of x in this example. In that first example with the cosine of x plus y, I wanted to be sure that it was safe to divide both sides by the cosine of x plus y. And it was. And in this example, I want to be sure it's safe to divide both sides by just the cosine of x in this example, instead of the cosine of x plus y, which is the first example. But in this example, it's just the cosine of x, and it is indeed safe to divide both sides by the cosine of x, because it will, we have established up here, it will never vanish, and that's by trig. The cosine vanishes at negative pi halves. The cosine would vanish. At pi halves, it would vanish as well. But notice this is an open interval, guys. We're only talking about the points strictly in between these two. You can't equal these two, either of these two values themselves. So the cosine can't vanish because he's trapped on this interval. Now he can actually, as it turns out, he can get arbitrarily close to 0 as the x gets arbitrarily close to either of these pi halves or neg pi halves, whichever one. But that shouldn't harm things for our purposes here, So that'll be all for that. And I don't want to turn this class into an analysis class. I'm desperate. I'm pulling out all stops I don't want to make this analysis one. I really want this to just be calculus one. Okay. Let's see, guys. You know what? This involves some talk about. Let's save this for the next video, and we'll move on to the next video. That would be rough to put that in this video. So thanks, guys. I'll see you on the next video. Bye-bye.